bubbles, some chemical streaks at uneven densities. So these internal imperfections bend starlight unpredictably, creating blurred planetary details and frustrating color distortions. And to decode chemical signatures from space, astrophysics first required the creation of perfectly pure optically glass lens. So there were imperfections in those space back in the 17th and 16th century, uh, which uh, which we struggled for a very long time. But when we got the perfect prisms, we could see that there were dark lines. There were some dark lines in the spectroscope. So perfection. So here comes Joseph von Fraunhofer. So he revolutionized glass making by making the most precise chemical formulas by systematically stirring the molten glass to eliminate bubbles and internal streaks. He eliminated all of the flaws of that time, and this flawless optical glass allowed prisms to clearly separate starlight into pure unblurred spectral lines for analysis. So here come so this is Joseph von Fraunhofer. So let's talk about his past. So when he was 11, he was working in a glass making factory, and he died very young at the age of 39, as you can see in the picture, 1787 to 1826. So he was a very famous person, and when he was dying, he revealed all of his secrets. But what happened that the country he was in, did not let them out. So, and the and this revolutionary glass making was only kept to the country, and it became a problem for Michael Faraday back. After that, it became a problem for Michael Faraday, and uh, he was when he was young, he was denied books, but after an earthquake, he got saved by the king of that place, and then given education. So this is the humble beginning of Joseph von Fraunhofer. So he revolutionized all of this and made perfect optical glass that allowed prisms to see starlight clearly. Spectroscope. So Fraunhofer invented the spectroscope by aligning a glass prism with a high precision serving telescope, and instead of doing a tiny blurry rainbow, this combination magnified the dispersed light into a wide, sharp spectrum. So this crucial optical integration allowed scientists to see and map macroscopic dark lines hidden in starlight. So after that, when we saw like when we put a glass prism inside with when we aligned them with the telescope, we saw in spectrum of light, it was a full spectrum with small lines. So that, and now we call that an absorption spectrum. There are majorly three spectrums which we'll discuss in the whole presentation: emission, absorption, and a continuous spectrum. So a continuous spectrum is, you know, that a full rainbow, and absorption spectrum is a full rainbow with some dark lines, and emission is we'll talk about that later in this presentation. So temperature of color. So Herschel 1800 experiment split sunlight with a prism and placed thermometers in each color band. Temperature steadily rose from violet to red. Crucially, temperature placed in the dark zone past the red edge registered the highest temperature, proving invisible heat rays existed. The historic discovery of infrared. So, ladies and gentlemen, do we have any questions? Uh, Soumya, do you have any questions? Hello, Aryan, are you here? Hello, Aryan, are you here? Okay, I don't. So in the 1800, there was William Herschel, and very famous scientist who discovered another planet. But in here we are talking about temperature of color. So what does that mean? He placed thermometers in each of the color band, and also put an extra beyond that uh, red red line, and then he observed then he observed that it was the highest it gave the highest reading of them all. And now this was the discovery of infrared. So they didn't know that time that why is that temperature rising more than the others. So okay, so Aryan, are you here? Hello Aryan, are you here? Okay, so ladies and gentlemen, do you have any questions? Soumya and Aryan, do you have any questions? Hello. So
I can understand.
do you have any question?
No,
Can you repeat what you said?
I can understand.
Okay. So, like, can you tell me which part you didn't understand?
Can you repeat?
Can you repeat, like, which part you didn't understand? Okay, so, uh, let, okay, so let me just explain that again. So, as you see that uh, this there is a picture of a prism, right? So what happened is that if it like inside it, if it is not perfect, the glass reflects light, and we get like very blurry images. We do not get we just see a very blurry rainbow. But when we place it in front of a telescope, we see a very broad uh, rainbow-like graph. So that is a spectrograph where there are colors, red to violet, and there were and the one that we saw, it had specific dark lines in there, the missing lines. So they were dark, and here now we are trying to answer the question, why are there dark lines in that specific rainbow? So uh, so did you understand till now? Hello, Soumya. Soumya, did you understand till now this stroke?
Yeah, I can understand.
Okay, did you understand it, right? Did, did you understand this till now?
Yeah,
Okay, so then a temperature of color. So there was another scientist, William Herschel. So what he did is that he took a prism, and he, like, as we know that a prism slits, right? So he placed a thermometer in each of the color, and also placed a red color and another thermometer beyond the red point. So and after that he got the color, the temperature of color, every color, and he seen that red was very high, but there was another but they he got another highest reading by the one that was not placed in that color. So that was the discovery of infrared radiation. So did you understand this one? Somebody did you understand this temperature of color?
Yeah, I can understand.
Okay. So, Aryan, I have a question for you. Aryan, are you here? Okay, well, you're talking later. So, infrared. So, Herschel discovered infrared radiation by placing a thermometer in the dark zone just past red light, a red starlight, expecting ambient temperatures. He found the highest reading of all. This proved the existence of some invisible heat rays, demonstrating that human eyes only perceive a tiny fraction of the universe's full electromagnetic uh, electromagnetic spectrum. So, uh, after discovering that, we just knew that this happens, but we did not have any reasons. So, Aryan, I have a question for you. Can you explain those dark lines in the spectrograph? Like, do you have any guess? Hello, Aryan and Soumya. Do you have any guesses on why?
Can I guess?
Okay,
Can I guess?
I think so. Who's this?
Yeah. This is
Okay,
Rohit.
so
Rohit.
okay, give a try.
I think maybe something related to the heartbeat, something like that.
Heartbeats. Are you talking about heartbeat?
Yeah. Yeah. Maybe like in the interstellar aliens, maybe the molecules of hydrogen and oxygen maybe combine to form the lines and fluctuations in the variations.
Okay.
Maybe. Yeah.
Okay. So, are you telling that certain elements are doing that?
Yeah. Because some molecules, maybe there's some like different, we don't know about them because god also we don't know about, so like some molecules we might not know about, so these molecules can create some fluctuations and vibrations and cause a heartbeat inside them, it signifying that there's some life in the planet other than earth.
Okay.
It's the beauty of astrophysics actually.
So, you're partially correct. So,
Yeah.
can you give a guess at the atomic level? Like, what's happening in those molecules and atoms that this thing is happening?
At the atomic level, um maybe some maybe some interconnections between the electrons and protons might create a nucleus, I think.
Electrons and okay. Uh,
Yeah.
so yeah. Okay.
Yeah.
So we'll get the answer
Yeah.
in the presentation only. Just wait.
Okay,
So,
okay, okay. Thank you.
so it was a pretty good guess. Uh,
Thank you.
so you were about those elements you talking about. You are right. So we'll just talk about that in this presentation now. So there was another person at that specific time. Like he did the he got the spectrographs in 1802. So he did that earlier. I think so. Fraunhofer did that in like 1814, I think so. And William Hyde Wollaston accidentally discovered solar absorption lines in 1802 by passing sunlight through a primitive prism. He noticed a few dark gaps cutting across the rainbow. Believing they were just natural borders separating different colors, he failed to investigate further, leaving the cosmic breakthrough to Joseph Fraunhofer. So he did that independently. So you cannot say that Joseph Fraunhofer stole that experiment. No, he discovered that independently. He did not know of William Hyde Wollaston's experiment. But what he, I think so, observed only seven absorptions line. He could not explain them. So, Joseph von Hopper got, I think so, 500, more than 570, I think so. So, Fraunhofer lines. So, in 1814, he meticulously mapped over 570 dark lines cutting across the solar spectrum using his advanced spectroscope. So, he labeled the most prominent gaps from A to K While he never understood what caused them, he proved these lines were permanent intrinsic properties of starlight, providing the foundation for chemical astrophysics. So, yes, one more thing, Rohit, I wanted to ask you. Uh, what do you do?
Yeah, yeah, yeah.
Like, what are you studying right now?
Huh?
Like, in which class are you? Are you doing college or doing something else?
Yeah, I'm taking a PhD in physics right now in IIT Delhi. Yeah,
Oh, uh, can you repeat the subject PhD in?
PhD in physics.
Okay, so like which particular section like have you done planetary science, black holes, stars?
Yeah, yeah, science.
Okay, like about which topic is your PhD based on?
I'm doing physics right now. Maybe I might do chemistry also, but yeah, mainly it's astrophysics actually because I'm very interested in the astronomy and stars and planets,
Okay, so
sun.
like your topic should be revolved around a specific topic, right? You cannot just say science. There are many things in science. So I was
Yeah,
thought,
yeah.
are you doing
Actually, see, there's a magnificent story that I'm reading, okay, because there's this one planet, okay, it's located around 722.78 million light years away. Uh, that's, yeah, so this name of the planet is X275. So that planet, okay, the thing is, okay, there's some crazy shit going on there, okay, because uh, there's water
oh,
in the planet and it's not discovered, okay, but the thing is that is my theory. So because the sun is rotating around the Milky Way and correct inside the Milky Way, so we can understand that the galaxy will be perpendicular to the astrophysic galaxy of light. So therefore by the distance we can use the hypotenuse to find exactly where that planet will be, and we can confirm that there's presence of water. So I talked about my professor with this one, so and like getting somewhere on the thing. So mainly my ideas about that planet and how we can get to the planet and extract its resources in case required.
okay. So
Yeah.
have you used the spectrography method on that planet?
Pictographic.
Spectrograph. Have you taken up
Spectrographic, no, no, actually we didn't need that one because we already used the Pythagoras theorem, so it's okay.
No, this was to confirm, like to try to get an approximate guess on what its atmosphere is made of. So if you try
Yeah, yeah, yeah.
spectrography on that, you may get a hint. Does it have the specific elements for life or not?
Oh yes, correct, correct. But the thing is like it's just a theory, so like we can't really like do anything about that right now, so just
Okay,
theory. So, or what
so
can we do? We
you
cannot
can
really test it
you
out.
should try that on that planet.
Yeah, maybe next year we can try. When we get to the planet, we can try. No problem.
What do you mean by getting to the planet? Are you gonna travel there?
Yeah, that's our mission. Where it's me and like one couple of friends. We are four people. We are yeah, we are sponsored by this one NGO. So we are
Oh,
planning.
okay, so good luck. So you'll
Thank you, thank you.
should try that. And if you want to find, like, do you know what star does it orbit and these other things?
No, as I said, it's just a theory. So like we don't know much about it. It's just coming up
Okay,
only.
so you can try radial velocity method to
Oh
know
yeah,
the
yeah, yeah, yeah.
the properties of its orbit. So if we see a if you see a dip in the starlights, if the sun is in front
Mhm.
of me and the earth will go around it, there would be a certain dip inside in the luminosity of that. So
Oh
uh,
yes,
I,
yes.
I'm not an expert on that, but I think so you should try that to find its orbital properties. Okay, so someone is raising his hand. Nanda Kumar has raised his hand. Hello.
Hello, Aryan, can you hear me?
Yes.
Okay, I actually came into this class because of my like curiosity on the topic of how astrophysics was like came into creation, but like this class doesn't have much to do with that because astrophysics, it's more of the like study of the astronomical objects, but like this doesn't
Okay.
really have much to do with that.
Okay, so there's a difference between astronomy and astrophysics. So, yep, it's sometimes easy to confuse on. So, astronomy is like the study, like if you know,
No,
like,
see, Aryan, I think I have one point to put out here
okay,
because I think you see the slide that you put here, yeah?
yes,
Slide you have put here. Just
yes,
give me some purple, some blue, some light blue, some green,
yep,
yellow,
yep.
orange. I think this is not astrophysics because it's just racism right now.
Why?
This, I mean,
Please, can you please keep your own political standings away from the topic? This is more
no,
about
no,
to do with
because no, this is no, this is very sad because see, because my friend, his
Rohit.
name is
I'm
Jay
sorry.
Pranav. His name is Jay Pranav.
I'm sorry
He,
to.
uh, hello,
Okay, okay, I'll,
can you hear me?
yes,
Yeah,
I can hear
yes,
you.
Can you
we
hear
can.
me?
Yes,
We can hear you. We can.
Can you hear me?
yes,
Yes, Rohit. Yes, Rohit.
Oh, okay. Yeah. So as I was saying, some racism is there. Yeah. So we need to fix that one. Yeah. Thank you.
okay, so I think so. Okay, I will not use the dark lines, the word. I'll just say
Yeah, we can change the slide. Maybe you can go to the last one or maybe next one. That's a better idea. Yeah.
this one.
No,
Rohit,
okay, this is a better slide. This is nice.
as I
This is nice.
said, please keep your political standings to the side
Yep.
and please come
I just
forward if you
No,
only
no, no.
want to
Please,
talk about
please,
the
Nandakumar,
scientifical.
please, Nandakumar, please.
okay.
Rohit, please
I'll,
maintain your decorum here.
I'll I just want to have a peaceful session. So,
I'm sorry,
Okay,
Aryan.
I
sorry.
don't
Yeah,
think it's related
Nandakumar,
to
sorry.
being
Okay,
racist.
I'm mute.
Okay, okay. So, yep, the difference between astronomy and astrophysics, it's like astrophysics is the study of things like these, where we find the temperatures of, uh, like temperatures, the motions, like it's related to black holes, stars, galaxies, and all of these things. There's differences between astronomy, cosmology, and astrophysics. So astronomy is more of the celestial body motions and type of that things. So the thing we uh, okay, I think so you wanted to say something.
Yeah, I was just trying to say, like, before Rohit cut me off, I was just trying to say that astrophysics, like, the method and like the principles of physics and chemistry in the
Hello,
study
hello.
of.
What do you mean I cut you off?
Rohit, please, you're
Okay,
cutting me off again. Please let me. Can you let
What do
me?
you mean? What do you mean? No, no, no. See, I don't like this. Okay, I don't like this kind of accusation on me. I think you should remove this guy from meeting. Nandakumar, I don't like him.
I'll
Rohit,
yeah,
No. I'm not. This
Rohit,
is
maintain your decorum.
racism. No, this is
Listen,
racism.
Rohit, please mute your mic and let me get
See,
my
Aryan, the
point
same
across.
slide is
Please,
back and the
Rohit.
same guy is back. This is an attack on my morality. I cannot.
it's nothing
Yeah.
racist. It's
Yeah,
about
this is all
science.
just science. And
There's
if you can't bring
But
up
I
your
feel,
logical approach, if you
no,
can't bring up
I'm
your
really
logical
feeling
approach
very,
to this
very sad. You know,
conversation,
this is, no,
Rohit, Rohit,
impossible.
Rohit, you
Aryan,
are
can we please
creating
mute this
nuisance
person?
here. I'll, it's yeah, it's
Yeah,
creating
so
problems.
as I was saying before Rohit cut me off again, it's more about the study of physics and chemistry in the study of astronomical objects. So astronomy is a part of astrophysics, as I was saying.
Uh, I didn't get it. Can you just repeat it again? Uh,
Sorry, pardon?
I
Told
didn't.
you repeat the line.
Rohit, we don't need your comments over here, okay? Please.
Okay,
So
don't be in.
I'm sorry. This is very disrespectful. This kind of talk is not allowed in this meeting. Okay, please. Yeah.
Okay,
I'm
Yeah, thank you. Just want to put that.
okay. So
trying to ask a doubt here and you keep interrupting the class and this is really, you're creating a
I don't
nuisance in
think
the
you're a real
class,
aspirant here,
literally.
okay? Because I think I know
uh,
more than you in physics, okay? And I
Just
think we
because
should
you're
have
in,
a debate about it, okay? Like right now. This is very important.
just because you're in some prestigious college doesn't mean my dreams and my aspirations
okay,
aren't as big as yours.
Uh,
No, 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 no. Absolutely
just
not.
to,
I will not tolerate racism. This is not good.
uh, I
Rohit,
don't,
please. You
you
don't
know,
even know what major you're going in. You just said physics, physics, physics.
Nanda,
You don't know anything about the pro. You're just a
Nanda,
fraud.
Nanda Kumar.
Ro- Please. You don't know anything about
Nanda
it. You're just
Kumar.
here to create a nuisance.
Nanda Kumar.
okay. Uh, Continue with
This
the
is a class. We need some silence. Yes? Thank you.
Please, yeah,
just
shut.
try to
Okay,
keep
Aryan, you can
the
continue,
peace.
please.
Okay.
Rohit, please shut up and let the
Yeah,
class
Aryan,
move
please
forward.
continue. Please continue. Hey, 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 what's the words? What's the words? What's the words?
Uh,
Please maintain decorum.
okay.
No, I don't think this is the kind of words that should be used in the meeting. Yes, I think we should completely disregard this one.
Okay.
No, impossible.
Guys, let's just try to keep the peace here. We are just trying
Can
to
we kick
learn
this
here.
guy? I don't think he's a real aspirant. He's just here to create a nuisance.
No, 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 no. I am a wonderful physics individual. I have very much knowledge.
Well, if you have that much knowledge that you're going to keep cutting off me and Aryan, how about you take the class?
Okay.
So Aryan, you can continue your class now.
Okay.
Please, please, sir, please, please, you can continue the class now.
Okay. Okay. So I think so. Let's just continue with the topic and let's forget him. So the labeling system. Uh, the Fraunhofer's A to K system assigned letters to the most prominent gaps in this solar spectrum, and he labeled the deep red lines A and moved across the rainbow to the violet K. Today, astrophysics still use these exact designations to identify critical elements like hydrogen, sodium, and calcium in stars. So the thing is that the labeling system we use, it's about the surface temperatures, and this one is about how its position in the spectrograph. So the red line, the B line, and the C line. Okay. So the C, so it just told about the specific position in that uh, in the spectrograph. So it did not have to do the people at that time did not think of surface temperature and these things. So people also thought that it was impossible to find the chemical compositions of things that are far away. I think so. Uh, Someone had said this thing that we cannot find the chemical compositions of far away things. So
Hello, hello,
yes.
hello. Yeah, Aryan, this is Rohit here. Yeah.
Okay.
Now, this behavior is totally unacceptable.
Okay, I removed you
No,
because
no, 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 no. I don't want an explanation. This is very, very disrespectful. Okay, because I don't think you have the authority to kick me like that. This is because I'm an individual who is very uh, interested in astrophysics, and I really want to attend this meeting, and that's why I think most of the people here are present, and I think you should
you
value
are
everyone's opinion like this. This is very,
You're really
very
crossing
sad
your
and
limits. Can
disheartening.
you? You're really crossing your limits. Can you
No, no, no,
please
I'm
So,
just
just
mute?
expressing my feelings
sir,
here,
please,
Kumar.
sir,
I need
please,
my
sir,
space.
it's a Aryan father here. Sir, Aryan is very
Well,
younger. You know very well. It is a lack
no,
of
but I think
time.
it's
He is
very
want to convey time
bad
to
actually to
present all
remove
things.
people like that.
Please,
okay.
sir.
If Let me tell something that if you really wanted to enjoy the class, you wouldn't have talked that way because if you create way too nuisance, it would be very hard to learn, right? So
No,
that's
no,
why I removed
absolutely
you.
no. But I'm not a kind of person like that. Never. But yeah, but I think the way
Yeah,
you have behaved is
Rohit ji,
very,
you
very
are
sad.
very senior guy. You are very senior, so you can guide to Aryan.
Hello,
Actually, he is very
hello.
younger.
We
He is
have not.
just learning
Hello, hello,
skills.
hello. Kindly listen. We have
Yeah.
not come here to
Yes.
listen your personal matters. Okay, here it is
Yes.
completely based on science. So keep shut and listen to the speaker.
Okay.
No, I'm sorry. I'm sorry, but this I want to speak here. That's
You
very
can
important,
leave.
actually.
You can leave. You can leave. Simply.
No, no, because this kind of disrespect, I'm not going to tolerate always. This no, it's not
Uh,
good.
रोहित जी प्लीज आप थोड़ा सा शांति बनाए रखिए, और सजेशंस कुछ हो तो प्लीज आप इसमें करते रहिए, बाद में डिस्कस करेंगे इस पे कुछ अगर ऐसा
ओके,
होगा।
बट मैं बस बोलना चाहता हूँ कि ये चीज बहुत गलत किया आपने, ऐसे रिमूव नहीं करना चाहिए था।
नहीं
इट्स वेरी
मैंने
सैड।
तो
मैं
रिमूव
बहुत
नहीं किया।
उदास हूँ आपसे। और
नहीं
जो
कोई
जो
नहीं,
जो जो भी
शायद हो सकता
आपने
है।
बेटे ने किया था और जो भी है वो मैं उससे बहुत उदास हूँ। जस्ट आई जस्ट वांट टू से दैट। या थैंक यू।
रोहित जी,
या
एक
थैंक यू।
अमृत महोत्सव है, आप प्लीज 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 सुन के प्लीज म्यूट हो
No, no,
जाए
no, no,
और
no.
ये क्लास को
Nanda Kumar,
कंटिन्यू
this
होने
this
दें।
problem happened because of you, and I don't want to talk to you because yeah, this
Okay.
is not.
I'm
सर
sorry
Okay,
प्लीज
Rohit,
guys.
but
कंटिन्यू
please
Now,
करते
let us
now
रहिए,
let's
continue
इसके
the
move
आगे
on.
class.
Let's
क्लास
move
भी है
on.
इसके,
Okay,
और
Rohit.
Yeah,
Okay,
let's move on.
be
रो,
Please
quiet.
let
Now
रो,
Aryan
we'll move
continue
on.
the class.
Okay, you're a
Let
good
Aryan
guy.
continue the
Rohit,
class.
you are a good guy.
ओके रोहित जी, आर्यन यू कैन कंटिन्यू क्लास
Okay.
प्लीज।
Thank you,
So
thank
Yes,
you,
please
thank you.
Aryan, please continue.
okay. So uh, back in Fraunhofer's time, he used letters to give uh, the position of these lines inside the spectrographs. So it would tell about the positions and not their surface temperature, the chemical composition, which was done uh, some time later by a woman named Cecilia Payne. She was the most brilliant PhD thesis ever. She wrote the most brilliant PhD thesis ever, stellar atmospheres. So we'll just talk about that later in the presentation. So emission lines. So as you can see in the picture, there are three spectrums: the emission spectrum, the continuous spectrum, and the absorption spectrum. If we have a very hot object, and if we get its spectrograph, it would be continuous spectrum. It is radiating all types of light. And an absorption spectrum, so this is a thing that we'll try to explain. And the emission spectrum, and Khrushchev revolutionized astrophysics by burning chemicals in a laboratory flame, and they discovered that these elements, vaporized elements, gave unique bright colored bands of light chemical fingerprints. And by matching these laboratory emissions lines directly to Fraunhofer dark solar gaps, they proved that distant stars share the same exact chemical compounds found on Earth. So this is the thing that by matching these uh, so it is very helpful if we get an spectrograph of a very far off galaxy, and if we have certain dark lines like those uh, and hydrogen sits at 656 point something nanometers, and uh, and helium, I can't remember, but if there are lines at those specific points, the 656 mark, other marks, it we'll find those absorption spectrums. So this is the solution of that, but at that time we still did not know what was happening on the atomic level. So the mystery was solved when scientists realized starlight passes through cooler gases in a star atmosphere. These gases absorb the same light wavelengths they emit when heated. So Fraunhofer dark lines was simply just chemical shadows proving that the chemical recipes of stars can be deciphered entirely from Earth. Okay, so at that time, when they looked to the sun, they had line which was not on Earth. Like we discovered helium on the sun before Earth, which is very interesting. So they named it after the sun god, the Greek sun god Helios. They named it helium. So this also gave us another element, helium. So after that, we like in laboratories we measured the dark lines for every other element possible at the atomic level. So at the atomic level, what's happening? So quantum mechanics explains that spectrography is driven by electron leaps. Electron orbits an atom's nucleus on fixed energy rugs. Passing photons are absorbed by electrons to jump up a rug, leaving dark gaps in starlight. When dropping back down, they release that energy has bright emissions line, revealing chemical identities. So whenever an electron, uh, in an atom, there's a nucleus and there's are the electrons orbiting. So there are very the distance between them is pretty good. So whenever an atom in the lower orbital gets an photon, and the photon has to be an specific frequency. So like, and if it's the specific frequency, it would go high. It would absorb that and go on a high energy orbital, and then it would re-emit that specific photon, and that photon's energy would be matched between the difference of the higher energy and the lower energy. So this is the answer on the atomic level. And like, I can't explain this very good right now, but I have few videos that are just based on this topic, quantum mechanics and these emissions. So I've explained very well in them. You can check them out on the YouTube channel. And I'm not going to discuss this, but because it's quantum mechanics is a very hard topic. And there are few more ways of getting photons, like right. So another way I remember was uh, when an electron goes very near a nucleus and gets trapped. So which gives us a continuous spectrum where so it means like we get every color, red, yellow, everything possible. And the three laws. So I did not go into the mathematics part of these laws, and also the PhD thesis, because it was very hard. So Kirchhoff's three laws define how different celestial environments form spectrums. So a very dense and a hot object would emit a smooth unbroken rainbow, which is called a continuous spectrum, and a hot glowing gas emit a cloud yields discrete bright bands emissions, and crucially, a cool gas sitting in front of it would create dark gaps absorption, revealing stellar chemistry. And like, if we just think that it helps us know the chemical composition of these things, so you'd be wrong. It can help us determine the uh, the distances between galaxies. Wilhelmina Fleming. So she pioneered stellar classifications by cataloging over 10,000 stars for the Harvard College observatories. So she devised an alphabetical system A through Q based on the star strength of stars hydrogen lines, where A stars had the most abundant hydrogen. Her foundational work paved the way for modern astrophysics. So, but now we have gone to another. Uh, Here it gives the strength of a star's hydrogen lines. How strong are they? And is going to be another one, which is in the modern, which one we use. It discusses about the temperatures, surface temperatures of there. So meaning of color. So what does color mean? So Annie jump cannons realized that star color maps directly to the surface temperature, resolving the confusion behind earlier chemical classification systems. By rearranging the mismatched alphabetical categories into definitive O, B, A, F, G, K, M sequence, she successfully organized the entire universe from the hottest blue stars to the coldest red stars. So now, this lady right here gave us like the modern one that we use, where this symbolizes the surface temperature. So uh, okay, so there was another one, Hertzsprung Russell diagram, if you have heard of that. It So it predicted these things very earlier, but uh, it still had a decade or two to wait. So now we are going to the most brilliant PhD thesis. So Cecilia Spain's 1925 stellar atmosphere is celebrated as astronomy's most brilliant PhD thesis. By introducing quantum physics to stellar spectra, she proved stars are composed entirely of hydrogen and helium. Her work overturned established scientific belief and birthed the modern era of stellar astrophysics. So, uh, okay, so her work gave us like helped us understand that stars are mostly made of hydrogen and helium, and there were few stars that we did not get lines of, which she proved that they were there. But what happens is that the hydrogen and the helium, like you need the electrons to jump between the orbitals, right, to get those specific colors. But here, what's the case? We weren't getting any. So, and that were in very high temperature stars. So what would happen is that if I gave energy to an electron, it would jump an orbital. But what would happen if I gave way too large amounts of energy? What happened is that the atoms were stripped of their electrons, and which also created another way of measuring distances. So uh, and so she proved that they were still there, but they were too hot to observe. It's like if my phone vibrates at 20 degrees Celsius, it won't do at 100 degree, right? So, so she proved that stars are mostly made of hydrogen and helium. I did not include the mathematics part. I remember a little bit of that. Meghnad Saha, she's an Indian. I think so. In the early 19th century, I think so. She did her work, and Cecilia Penny used that on on the grandest scale of the whole star. It it assumed that the whole star was made up of hydrogen, and there were few terms that I still do not understand that 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 are accountable for how many electrons and how many atoms, how many electrons is it the gas gaining or losing, ionization energies and these stuff. So I'll try to understand the maths and give another presentation on this maths of stellar atmospheres. So Earth spring rest of diagram. So back what motivated her to do this was I think she attended uh, an lecture, a webinar of some very of one of the most famous astrophysicists there, and she thought her work was wrong, like something was wrong, and she did this, and like this Hertzsprung crystal diagram is like would have predicted Cecilia's Penny by a decade, but her 1925 PhD thesis proved its ultimate physical validation. So, like as you can see in this picture, there's luminosity, temperatures, and but in that time, uh, what happens is that there was nothing on the temperature Kelvin. This that was just there. It did not have anything to do with that star. So it's a changed. I should have given the old one. So by applying quantum mechanics to stellar spectra, she proved that the diagram horizontal axis directly map precise surface temperatures, transforming an observational sorting chart into a mathematically sound blueprint of stellar physics. So this is the modern thing that. So this is a modern diagram that we use, but back in that day, the horizontal axis did not map the surface temperatures, the expanding universe. So I always like to uh, add a slide of this of how does it help us understand that the universe is expanding and stuff. So spectrography ultimately revealed the expanding universe in the 1920s. Edwin Hubble analyzed light from distant galaxies and noticed its spectral lines were consistently wrapped towards the red wavelengths. This universal cosmic redshift proved galaxies are rapidly flying apart, transforming astrophysics from a study of individual stars to the science of the entire changing universe. Okay, so the method is like this. If I have a spectrography of an galaxy, first we will measure the wave, the rest position of hydrogen lines in the spectrograph. Let's say that they that are like uh, 700 something, and what the equation is this: we will first get z, which would be the observed wavelength minus the emitted wavelength divided by the emitted wavelength. And let's say if we get an answer of 1.1, we will find its recession speed, which is point 0.1, the z times the speed of light, which would be 30,000 kilometers. And we know that it's accelerating away from us at a speed of 30,000 kilometers. But to get its distances, we have to use the Hubble law, which is the speed divided by the Hubble's constant, which is, let's say it's 70, so which would be 30,000, uh, 30,000 minus 7 divided by 70, so it would be about 1 point something billion megaparsecs. And parsec is 3.26 light years, and a megaparsec is 1,000, uh, millions of times that. So, yep, this is how it helps us understand the expansion of the universe, like the expanding universe. It just gives a proof of that. It does not explain why does that happen, and why is this thing of being observed. It's because of the expansion of the universe itself, because the spaces between two things are getting larger and larger. What happens is that the photons get stretched, and in physics, quantum physics, what's the case is that if it has a longer wavelength, it has less energy, and if it has a shorter wavelength, it has very high energy. So it's getting stretched, and that's why it's getting shifted to the red end of the spectrum. And this is very like pretty clever way of finding these distances. And the other thing, like the Cecilia Payne's work, was that of the Cepheid variable stars. I don't know I don't know who discovered or find this way of calculating the distance. But what happens that in helium, in some stars, the Cepheid variable stars, what happens is that they have pulsations in brightness. Sometimes it's low and sometimes it's high. And doing by using the inverse square law very wisely and finding uh, the periodical time of these delays, mathematicians do some tricks. I can't remember uh, how they did that, but they used that and found the distance by using the inverse square law. So if this is how we measure distances, and it just randomly came into my mind. So, ladies and gentlemen, do you have any questions? Soumya and Aryan, do you have any questions? Okay, I don't think so. So,
I have a question.
okay,
Um, Hi, my name is Adriana. I'm from Indonesia. Uh, I'm a beginner to learn physics and related to astronomy. I'm also a beginner with this. Um, and I joined a meeting related to astronomy. The speaker said that the expansions of universe uh, somehow it's related to the Earth. It's like moving. So the global warming itself is also affected by the Earth that's like alive and also moving. What do you think about that? Is that related of the expanse of the universe as well? Thank you.
uh, I like. I didn't understand what was the question. How are you relating? I did not hear it quite well. I think so. You were trying to say something about the expansion of the universe and the Earth, right?
Yes, like global, it's related to global warming as well. Global warming is like related to the
Okay, okay, okay.
expanding of the
I got it,
universe.
got it.
Yes.
So it's not related to global warming. Is not related to the expansion of the universe. Uh,
Mhm.
Global warming is just uh, the greenhouse gases getting trapped and accumulating more and more heat. So it's not related to the expansion of the space. I think so. We are blaming other factors for this, right? So did you get it?
Yes, I got it. Thank you. Thank you.
Okay. So, ma'am, where have you joined from? Like, have you joined the first time?
Yes, this is the first time.
Okay, so like, what work are you doing right now?
Uh,
Are you
sorry,
are you
what's
are you a student right now?
no, but I plan to continue a PhD related to social science and
Okay,
uh, connecting with the astronomy.
okay, social science and astronomy.
Yeah, yeah, it's
Okay,
kind of like new
okay.
thing, but I want to try it.
I can give a suggestion on like uh, if you want to connect social science to astrophysics, you can talk about how like what are the different mindsets that we need like to progress further and further in science is like the one thing is we need is transparency that Joseph Fraunhofer said to us. It needs full transparency and uh, tolerance. So I think so. One
Uh,
way is yes.
yes, Aryan, um, if you don't mind, can you repeat again in the WhatsApp group because I couldn't get some words from that. If you don't mind, you can please repeat again in the group WhatsApp group. Thank you.
Okay, okay, okay. And so summary. Astrophysics fundamentally transformed how humanity reads the cosmos, and by combining perfected optics with spectrography, pioneers turned simple telescopes into chemical laboratories. Their collective breakthroughs prove that the entire universe obeys identical physical laws, revealing a shared uniform chemical blueprint inside the invisible wavelengths of the starlight. So, okay, uh, we have we have done with the presentation. So, any further questions by anyone? Hello. Few people have joined: Adriana, Oves, Nafisa, and Punch. So, are there any questions by anyone? Hello.
No, very good session.
Okay.
Basically, Aryan, can you tell you something about what you are doing? Basically, I'm teacher, and
Oh,
when I read your message, then thought that it's necessary for me to join the um, talk that you are presenting. I don't know anything about you. Kindly introduce yourself.
so, sir, I'm Aryan. I'm 13 years old, studying in 8th grade. I'm just excited about these astronomy and stuff. So I make presentations about them, try to explain some few topics of astronomy to uh, the people.
Very good, very good. It is a nice attempt and it's a nice try by you. And the things you were discussing are a bit broader in concept that you will study hopefully after 2 years in detail in science, but you are exploring them before 2 years. It's a good sign. And observing your way of talk and your way how you are handling the question answer sessions, it was very good. And overall, a good session, good session.
Oh. So, sir, what do you teach?
Basically, I teach students science and mathematics.
Okay, sir. So, which institute?
It's government runs institute, government high school. I'm from J&K, Jammu and Kashmir.
Okay, sir. So, okay,
Sir,
so
you are joined from JNK? I'm
Yes.
Aryan father, sir.
Oh, hello. Good evening. Good afternoon, sir.
Good afternoon, sir. Actually,
So
uh,
very nice. It was a good session delivered by Aryan, and the way he handled the situation, the question answers, very nice.
yes, yes. Actually, kya, he is connect with also with the scientist always.
Oh, good, good.
So and actually he is interested in science, so that's why I'm just connect with the scientist. He read many books about the science and all.
Very good, very good, very good. I hope he will, in after a few years, he will be having good command over science and the
Yes,
concept,
yes.
and he will
He is
deliver.
very younger now. He is very younger.
Yes, yes, yes. I
Okay. So actually, I have also visited in JNK in Channi Himmat.
oh,
Yes, Jammu. Okay, so Aryan, you can continue. Some other person is also join your locations. So you can, sir, you can feel free to join his Aryan group. Now this session is recorded and also put in the YouTube channel also.
okay, okay,
So you can join the Aryan WhatsApp group. Then you have any kids, other school kids, if you want to join with Aryan, then you can also share the all.
okay.
Okay, sir. Thank you.
Okay. So, are there any questions or anything wants to add something? Soumya, are you here? Adriana, okay, okay,
I
I'll.
just I just appreciate this meeting, and I'm glad that I already joined your WhatsApp group, so I
Okay,
know how to study over there. Thank you.
okay. So, so did you understand the topic?
I joined. I didn't join from the start. If you don't mind, you can share the topic again. I mean the power, the content in the group again, so I can see it again, please.
Okay. So,
Thank
should I
you.
ask you a question? Hello, Adriana.
No question for now. Thank
Okay.
you.
No, I said that. Can I ask you a question, if you don't
I
mind?
hope that I can answer. I hope I can answer. Because I'm a beginner for this,
Oh,
Aryan.
so, uh, do you know why is glass transparent?
No, I don't know.
Okay, so, uh, if you had heard the emission part earlier, so it said that photons, like the electrons, absorb certain specific frequencies of wavelengths. So that is the main reason light is transparent. They just pass through it. If there's nothing to be absorbed, why would it wait? Like, so, yep, that's the. Uh, so, Adriana, do you have any suggestions on what should I present next?
Um, Aryan, I think it's kind of difficult for me um, because the sound, your I don't know, my smartphone. I'm joining with my smartphone, so some words not clear.
Okay,
Yeah, sorry. So I will ask you in the, if you don't mind, we can talk in the group.
okay,
Yeah, and I will leave now. Thank you so much. Okay, I will
okay.
join the group and talk,
Bye.
chatting there. Thank you. Bye. Thank you.
So, bye everyone. I think so we should end it. It's 12. Hello, David. Are you here? Uttam Shah. Uh, I think so. We should end this meeting. We have uh, 10 minutes so both. So thank you everyone for
I'm
joining.
here. I'm here.
Hello, hello,
Hello.
David.
Hello, I can hear you.
Okay, okay.
Hello.
Yes, sir.
Yes, I want to know that what was discussed in this session because
Okay. So we just discussed about the birth of astrophysics. On there was a problem about of spectrographs. There were few missing lines in the on the continuous spectrum of the sun. There were few missing lines, so that was to be answered. And to answer that, there were many scientists trying to explain what was happening. and we now have the solution. It's about electrons going up and down orbitals, which uh, which are the cause of those missing lines. And we just discussed about few more personal personalities like Cecilia Payne, the most believed PhD thesis. So we were just talking about that. And if you want to know more, you can just check out this video on my YouTube channel. I upload these sessions on my YouTube channel.
Okay, so what is the name of your YouTube channel?
So Aryan Astrophysics, if you search that, you'd get that.
Okay,
Okay.
okay.
So should we end it, or do you want to say something else?
Can I ask you something?
Yes.
I mean, are you a student or a professional? I mean,
Okay, I'm not a professional. I just do it on my own. You can say I'm a beginner. I like I just do it out of passion. So I try to explain few concepts of astrophysics every week when I get time. So it's not professional.
oh, nice.
Okay.
I mean, you are a student, right?
Yes.
Okay, I'm also a student.
Okay. I'm in eighth grade right now.
Oh, you are 2 years younger than me then.
Okay.
Where do you live?
So right now I am living in Ludhiana for my education purpose. I was firstly born in Bihar, but living here for my education purpose now. So my father has sent a WhatsApp group. If you want to join, you can join it.
Yes, yes, I'm.
Okay.
What's your book? I'm from West Bengal. Yeah, yeah, I heard. Nice. Right now, I'm a student. I study in 10th grade. हाँ, kind of मैम मुझे interest है. हाँ, 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 yes, yes. मैंने नहीं दिया था. मैं इस साल देने का मतलब ये गोल है मेरा.
I'm fine. Good afternoon. Everything is going fine. Thank you very much. Yeah, I think so. Yes, we're in this. I think yes, we're in the same group. I'm so much interested in science.
Hello, David. Are you here?
Okay. Okay, thanks.
David, like, what do you do? Are you a student right now?
Yes, I'm an engineering student.
Okay, so which year?
Yes?
In which year are you studying in college?
Okay, I'm in my first year.
Okay. Uh, is it electrical? Which is it? Civil or electrical? What type?
Automotive.
Okay. Okay. I did. There's noise from your side. Okay. So I didn't get that, but I think so. You know more than me if you are in engineering first year. So okay. I think so. We should end now. We have 20 minutes about. So bye everyone. Bye bye.
Okay. Okay. Bye.
अच्छा अच्छा ठीक है ठीक है हाँ हाँ ठीक है